Okay. Uh, okay. Uh, okay. Today we will uh, learn about divergence. Divergence. So, what a divergence is, uh, we first of all we did know what a del operator is. Del operator is nothing but I cap del x plus j cap del y plus k cap del z. Now, previously we learned that when this grad operator acts on the scalar phi, this gives I cap del phi del x plus j cap del phi del y plus k cap del phi del z. Now, now, uh, what we will do is that we will see that this gradient operator, when acts upon a vector function a x y z, what it does is that it takes the first component x and did its partial derivative with respect to x. It takes the second component and partial derivative with respect to y, and the third component and partial derivative with respect to z. So these two are vectors, and which gives a scalar, which gives a scalar. So, so the divergence is the scalar product of a vector with respect to del operator, del operator. That is this operator, del operator. We will first see some examples. Examples. Let's suppose, let's suppose A is a position vector, that is R. Then when this acts divergence upon the position vector, this gives del x, del x plus del y, del y plus del z and del z. So this becomes 1 plus 1 plus 1 equals to 3. Now, when this A vector becomes r cap by r square, then if I take the divergence of r cap by r square, this becomes 4 pi. This becomes 4 pi, a constant. constant. And this result is very important for the electric field obeying Gauss law. That is, uh, okay, let's suppose there is a point charge here, point charge of capital Q, and around this, around this uh, capital Q, electric field is radially outward. Electric field is radially outward. So the electric field E of this capital Q is 1 by 4 pi epsilon naught Q by R square, or Q by R square r cap. So, so this is the form we were talking about. This is merely a constant Q by 4 pi epsilon naught, and this r cap by r vector we are talking about. So when we take divergence of this electric field, this becomes Q by 4 pi epsilon naught divergence of r cap by r square. So Q by 4 pi epsilon naught into 4 pi. So 4 pi cancels out. So it becomes Q by epsilon naught. So epsilon naught divergence of E becomes Q. Now, if we have a collection of electric charges, let's suppose it is Q1, Q2, dot 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 Qn. For each of the electric electric charge, we have this law, that is epsilon naught divergence of E1, the electric field due to Q1, that is Q1 epsilon naught divergence of electric field due to Q2 equals to Q2 epsilon naught divergence of electric field E3 equals to E3 dot 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 epsilon naught divergence of electric field En equals to Qn. If now if I do the summation here, this becomes epsilon naught divergence of the sum over all electric fields Ei equals to the sum over all charges Qi. And this summation of electric fields is the net resultant electric field at a point. So epsilon naught divergence of E equals to Q enclosed. This is total charge in the volume, and this is the resultant electric field. Now we will now see the geometrical interpretation of electric field of divergence. What is the geometrically means this divergence? Now let's suppose we have a three-dimensional Cartesian coordinate here, x, y, and z. And also let's consider a parallelepiped of infinitesimal sides. Parallelepiped of infinitesimal sides. That is, this is dy, this is dx, and this is dz. Now, the volume of this parallelepiped d tau is dx, dy, and dz. Now, if let's consider a vector here, a vector. Let's consider a vector a x, y, z. So this is, let's consider here this parallelepiped associated with this vector a x, y, z. So the this is side 1 and this is side 2. The value of a on the side 1 is a y minus half dy del a y del y, because this length here is half dy, and we are considering first the second, that is the y component of a. Now what is on this side, the value of a is a y plus half dy del a y del y. So the net change in flux, so net flux along y direction is delta y equals to, okay, let's suppose this delta y is the net change in the a vector, and we call this delta phi the net flux along y, dx dz equals to, this ay and ay cancel out, and this becomes dx dy dz multiplied by del a y del y. Similarly, net flux along other directions is delta phi x equals to dx dy dz multiplied by del a x delta x, and net flux along z direction is delta phi z সমান dx dy dz del az del z. So total flux that is leaving the volume is delta phi x plus delta phi y plus delta phi z, that is dx dy dz, and this is d del ax del x plus del ay del y plus del az del z. So this becomes d tau, divergence of A. So divergence of a vector multiplied by this elementary volume becomes equal to the net flux of A leaving or emerging from that volume. That is, we are having an infinitesimal volume here of d tau, and when we take the divergence of A at this point, this the flux emerges out of this elementary volume. So divergence of A is nothing but d phi A by d tau. So this is the net flux emerging per uh, unit volume at point P. As let's suppose this is point P. So net flux emerging per unit volume at point P. So this is the significance of divergence. Now let's suppose A is a fluid velocity V. A is a fluid velocity. We have a, let's suppose, a fluid here moving along. Let's suppose this is x direction, and we do consider a elementary volume d tau, and this d tau associated with it a velocity v, fluid velocity v. So when we take the divergence of v, this becomes d tau d phi v by d tau. That is net flux emerging per unit volume at this point for the velocity. So this is nothing but the number of fluid particles, call it fluid particles, fluid particles that emerges per unit volume, per unit volume. So now rho here, the density of any fluid, if I take as density here of this fluid, then del rho del t denotes how the density is changing. That is, this denotes actually some source, because at some position the particles are creating. That's why this rho changes with respect to time only. So as we have conservation of conservation of mass in Newtonian mechanics, so these two, living and emerging, have to be equal. That is, how much particles are living in this volume must be equal to the how much is uh, creating. So assuming no source or sinks, this divergence of V becomes equals to minus del rho del t. So number of, okay, so this is our equation of continuity. We will stop here.